Okay, first of all, the philosophy for the XIV, prior to IBM getting involved, and I guess it will continue if it can, is to select multipathing software that is integrated into the operating systems. So recently, a lot of the operating systems are starting to embed their own multipathing software. And that started to occur right about the time that XIV was coming online, and so they chose to only go with those solutions exclusively. And they didn't want to use any proprietary storage vendor solutions for obvious reasons. There's just a lot of complexity to have to support, and they were a small company. And so they wanted to do just the multipathing software that was provided by the OS. Whether they get away with that for too much longer, I don't know, but that's where, to date, that's where all of the experience is, just so that you know that if you select a multipathing software solution off this list, it's been relatively well traveled. If you pick something like PowerPath or Veritas DMP on a different operating system, then you're in new discovery mode for those. The test is starting to go through all the different combinations of OS and multipathing software, but they're just getting started. So here's what we currently have some experience with. For AIX, we have MPIO. We use the default path control module, which currently is only supported in active passive. So for AIX, we don't currently have a dynamic multipathing solution. The multipathing is active passive. So there are plans in the roadmap that STD PCM will pick up support, but that is not currently available. And in order to add the XIV unique device type attributes, there's an install P that you'll need to get, or your customer will need to get and install. And then you can see that with Linux we use Device Mapper. There isn't any special software that needs to be added there, although you will need to edit some files and recompile the kernel. And there's information on how and procedures on how to execute all this. For Solaris, we're using their native MPXIO. You have to edit a .conf file. For HPUX, they ship with DMP software from Veritas, and there's an ASL to enable support for XIV that you have to get from the XIV website. And Windows MPIO, you need a DSM from the XIV website. And then VMware is just the software that they provide, and there isn't anything that you need to add in order to enable that. So just a real quick overview on the multipathing software. So native STD is currently not supported. This is sort of a first stab at physical topology in terms of what best practices would be. You want to have all 6 interface modules working for you for your volumes. It's important in order to achieve the full performance from this architecture. So and it's because of the parallel nature of the architecture. If you're going to take full advantage of it, you want to have all 6 interface modules working for you. You don't really need more paths than 6. So you can, there's no performance to be gained in most cases for going beyond 6 paths. And that's especially true if you're using the 4 gigabyte cards in your host, 4 gig HBAs. If you're using 2 gig HBAs, certain workloads may be able to benefit from more paths. And so in those cases, you would go to 12. And when you're dealing with a whole bunch of different hosts, it's important to try to make sure that you are balancing across all the interface modules. This is what the WWPN decode looks like. So this could be useful in cases where you're helping to troubleshoot connectivity issues. You might need to get into a switch, for example, and see if the XIV is logging into the switch. If you see a WWPN that adheres to this format, then that's an XIV. You can see the unique number 1738. If you see that, that device is XIV, and then you can see also further how to break that down as to where that WWPN is connected. So you can map it to the module and port within the module. Some of the CLI commands that would be useful is, well, the FC port list is a good one. You can see that only modules 4 through 9 are represented here, because those are the only, well, the nomenclature is port, module, and then module number, and then port number. And you can see that these are all the ports for all 6 interface modules. And you can see whether the link is up, and you can see what the topology is set to. Notice that 1 on each module is set as initiator. So these are the ones that are by default reserved for your remote copy. And this command will show you what's logged in. So this is equivalent to if you go to the GUI and to the host mapping menus, where you'll have a drop-down that will list the WWPNs that are logged in. This is that same output. If you specify logged in equals yes, then you get only the initiators that are logged in to the XIV. Well, this is dynamic. However, it adheres to the same, conventions that all of the other storage devices do. Namely, it doesn't mean the host is still there. It just means that that host logged in and never logged out. Well, it's SCSI 101, right? I mean, or I shouldn't say SCSI, it's FCP topology, but you can't. The storage device can't arbitrarily log out initiators. So it is a host operation to log it in and to log it out. So if you see the WWPN represented here, that means a host logged that in and has not subsequently logged it out.
If the host sets the logo, then it will be easy for operation.
That's right. It will not appear on the list. Exactly.
Yeah.
Exactly. So this is good information. Obviously, you need to make sure that your host HBA is successfully logging in. If you don't have this, it obviously it's not going to work. But because you have this doesn't mean it's going to work either, right? Because the host could have logged in and then gone away for some other reason.
Yeah, but that means you have an effective connection to your device. I think you can start to map the worldwide port name to your physical volumes.
Yeah, but it still doesn't necessarily mean that it's going to work. This says that the login was successful. Now, yeah, at one point it was successful, and since that successful login, there has not been a subsequent successful log out. So that's what that represents. The queue depth is rather large, 1,400 per port, 256 per volume, and in order to take full advantage of the performance from XIV, you want to have a sufficiently high enough queue depth set on the host.
What? So you mean logging?
This is queue depth.
How many hours you
Right. Right.
before he won't accept anymore.
Yeah, there's login limits also, and I think it's 512 per port and some large number aggregate across the box. But this is referring to queue depth. And queue depth on this product is much more significant, I guess I'll say, than on other products because, again, of the parallel nature and the fact that there's always sort of a built-in latency between drawers that I spoke about before, that that you want to take advantage of the queue depth in the interface module in order to get the performance out of it. And that's mostly because of the elevated inter-module latency. And this is one of the numbers that's still being worked out, and there'll likely be some, hopefully not a complicated formula, but there'll be some rules of thumb to sort of adhere to when you determine what the queue depth should be. 64 is a good, everybody agrees at this point, is a good starting point. So, which is pretty high, I think, for a lot of storage devices. If you look at the host, attachment guide, I think that this is relatively high, but I think by default, AIX sets it somewhere around 20.
That's the default on Windows, so I thought it was up.
It could be, yeah, I don't know. So 64 is kind of a minimum, and there may be cases where you're going to want to go higher than that. So just keep that in mind, and then there'll be more information coming out on that later. Now, you guys have probably run into scenarios where reserves are getting in your way. The XIV supports both SCSI 2 traditional reserves and the SCSI 3 persistent reserve. So you may see both of those depending on what the host is requesting. You can see the reserve using the vol list command, but you have to specify the XML format -X, and there's a field in there, reserved by value, that will actually list the WWPN in the case of a traditional reserve, or the reservation key in the case of persistent reserve. There's also a command to clear keys, which is kind of nice. Yeah, so that's good. We've always had problems with that. STD provides a utility that will clear reserves, but not all operating systems and multipathing solutions have that, and sometimes it can be a problem. But you have it on SVC if you're using STD.
Yeah, but you're talking an external solution. I want an internal.
Right. Okay.
Solution.
Yep, that's correct. So this is nice to have. There's the XIV uses LUN 0 by default as the controller LUN, so this can sometimes trip customers up. I actually got caught by this, and that's how come I know that if you try to send read-write type commands to LUN 0, you get a check condition, and I wrote down specifically which check condition you get. Invalid opcode. So if you, when you're mapping LUNs, you'll notice that LUN 0 is already assigned. It's not available for you to add a volume to. However, you can override that and add a volume to LUN 0. If you do that, then that's fine. LUN 0 will now behave like the volume. But by default, LUN 0 is mapped out, and it's set aside for the controller. If you don't override it, then LUN 0 behaves like a controller.
Why?
At some point in the future, they're going to do allow in-band management commands. And when they do that, they'll send them those commands to LUN 0.
It's like an ETM device you have on the desktop page, the LUN 51.
Yeah.
The same.
Same thing.
It's like a tape library.
Yeah.
Does this present a problem to some competitors like Sun or somebody that they have very structured one?
Yeah, and that's why I'm pointing it out. And I don't know all the various problems that it's going to cause, but I want you to be aware of it. And I know that certain OSs, you're going to have to override that with a volume. And some of them are going to want to see LUN 0 as a controller. And if it's a volume, they won't talk to it like it's a volume. So and I don't know all the different behaviors for all the OSs, but just be aware that they all treat LUN 0 a little bit differently. Okay. That's all I had on host connectivity. You guys have any questions on any of that or any?
About the connectivity, normally we have 6 interface module where we can have 5 channel cards. So normally for each operating system, I will not say we have a limitation, but there is a good point of view to decrease the number of parts we will have for storage. For example, in X, the maximum in SATC is also 4 parts.
People go to 12 cars and it actually causes problems.
Yeah, I know the best practices for, I know I'm very familiar with best practices for DSAK connectivity, and there really is there's no need to go over 4 paths in that case. And the only reason you would do that 4 paths is if you had 4 HBAs in your host, and then you would map those one-to-one HBA to storage port. Going beyond that is not buying you anything in terms of availability or performance. So, but what it does do is add additional overhead when you're driving error recovery, because all those paths need to be retried and failed and so forth. So there isn't any point in it. But as I pointed out on one of the first slides here, this one's a little bit different because we do want to use all 6 interface modules. And so minimally, we're looking at 6 paths, and then
One port on each module. I mean,
1 port on each module.
so it's got a round robin.
We have 6 parts.
Ideally, you would have dynamic multipathing that would round robin across all 6 interface.
What I mean is that if I have 3 AA hosts, then I round robin the first host to one set of ports, second host to another set of ports, third host to another set of ports.
Yeah, that would be one way to do it. You could also do it through the same set of ports, right? I mean, you're in a fabric, so the back-end storage ports can be shared across multiple front-end hosts. It's better to spread, but it all depends upon how many hosts are we talking about, right? So if in your example, if you only had 2 hosts, right, then yeah, why not go ahead and multipath them across a separate set of interface ports?
Is there any kind of post attachment guide for the XIV?
It's being worked on,
Because
so no.
for IX it's a point of view, for VMware it's another point of view, because for VMware
Understand that.
you have to make the fill policy, so for the S4K it's MRU, so most recent use, for the SKK it's fixed.
All those things, they all need to be ironed out, and we're not there yet.
Because if you want to install a machine, for example, if the machine came from, and I don't know, tomorrow to a customer, the customer wants to use an operating system which is listed on the
Everything works, but what we're talking about here is optimal configurations, and we're still trying to figure out what they should be for the various configurations.
There is sometimes, for VMware it's very important to know which kind of fill policy do you use, because if you have a failure to an HBA on the VMware server,
VMware is only active passive though, right?
What does that mean in this case?
because it is
It means a couple different things depending on the active passive solution. Some of them, like AIX, will do active passive, but if you've got a group of LUNs, it will alternate the active path on a per LUN basis. So from an aggregate, full LUN, set perspective, you're balanced across. Although you're not multipathing, each LUN is not multipathing across multiple ports. Aggregate, you've spread your load across all the ports. Does that make sense?
You're saying that if I say exactly one LUN from the Xbox, it's going to give it 6 parts, it's going to use 1 part,
That's correct.
5
That's right. And so that's why the number of LUNs that you're using, if it goes up, then your efficiency for load balancing in an active-passive configuration goes up,
So ideally,
and goes down for the reduced number of LUNs.
yeah, 6 or 12 LUNs right there, 24 LUNs. So
But if you got 1 LUN, maybe 1 path is all the bandwidth you need. It's an all depends thing. But it's not optimal because of the configuration we've got here. If you've got high workload, you want to take it again. You want to take advantage of all interface modules. And if you're in an active passive configuration with only one LUN in your example, worst case example, then you're not taking advantage of the full bandwidth of the storage system.
If a customer has, let's say, a Windows 2003 server and is using SDD to reach a DS8000, and now he attaches an XIV, does the SDD handle that machine or no?
Nope.
So he has also to find a new solution for the Windows 8000, for the DS8000.
Well, is he using the old native STD or is he using the Windows MPIO with the STD PCM or DSM? If he's using that, then Windows will handle both. It's going to treat this device as a default device. It won't, it won't have any specific behavior for this device. It'll treat it like a generic SCSI device. But that would work. But if your customer is using the native STD, that native STD won't support this device.
So that means I will attach this machine to an X server. I will see FC, generic FC list in the attribute of my item. For example,
Which server type are you talking?
An X server.
AIX?
X.
No, because there is an install P here, see? And it will install the XIV unique attributes. So it'll show up as a 2810.
So that means you will create a specific queue there for the IPs and specific setup inside X to access the device.
It does mean that, yes.
Because, for example, if you attach a device and you don't install any kind of attachment script, it will be seen as a generic file of write. That means all the queued FC